While you guys are settling in, I will just briefly introduce myself. Raj Joseph, founder, CEO of DQLabs. We are a modern data quality platform, DQLabs, and what we primarily do is combine three different capabilities: data quality, data observability, and semantic layer as one unified platform and leverage all of this stuff. Today's topic, as you might have seen already here, is unlocking the power of generative AI. How many of you guys today use some kind of data quality tools or solutions or program or processes in your environment? Few hands. How many of you guys are experimenting with Gen AI? Few. How many are you guys taking the Gen AI experimentation and applying on data quality checks or processes? You. Three. And so we all know that data is very important and needs to be high quality. Garbage in, garbage out, we know all of that stuff. So in this session, we're not going to talk about how high quality data is a must for training models, but we're going to be looking from an opposite view in terms of how generative AI could be used to find and produce high quality data. And I'll be going through a process of slides to bring it to the architecture, and then also a little bit into a demo at the end. That's what I'm going to be doing. At the end, I will give you 5 minutes or 10 minutes, depending upon how fast we go, to ask any questions. So please do bring it. So how do we unlock generative AI for the purposes of modern data quality? So I decided, what is the best place to ask? It's ChatGPT, right? And that's what we're bidding. So I said, I raised my hand, and I said, let me ask. So this is what ChatGPT did. I don't know if you guys can clearly see this. The question I asked is, how can Gen AI help data quality? And I got this big content, and I know you guys can't read far away, so I just kind of made it as bubbles, big bubbles. And if you see all these bubbles, it's all over the place. NLP, of course, we are talking Gen AI, it needs to be there. We are talking data cleansing, data remediation, data quality monitoring, and we're also talking data governance and compliance. And then more, we are talking anomaly detection, data augmentation, data enrichments. That's pretty much, as far as I know, that's data management. The whole data management sector is here. So, okay, maybe there is something here which I'm not reading it properly. So I took that, started color coding it, started labeling them in a way my human mind can understand, right? So I just kind of color coded into two categories. One, validation detection. And the other one is more around anything that I'm changing the data. So the bottom piece is more like, is there an issue or not? Can I identify something bad? While the upper quadrant is more around, how can I fix it? So that's the main two quadrant. Just like anything else, there's got to be some anomaly. So I'm just going to ignoring this piece for the time being. And NLP makes sense because it has to be the way of interaction. And that is all ChatGPT is all about. And furthermore, DQLabs, that's what we do. Observe, measure, discover is all around this, understanding the context and identifying the issues, while on the top is all about remediation. This is the platform offering that we do. So I just put my labels there. Then I took that. Okay, so let me take that observe, measure, discover. Observe is primarily for unknown issues, using ML algorithms for identifying unknown issues, using benchmarking, deviation, anomaly detection, things like that. And measure is for when you have organizations, both data organically produced within your company and also inorganic, meaning partner data coming in from external sources. You know the problems that you have with your supplier data or partner data. So these are known issues that needs to be managed and measured, and that's the measure piece of it. And the third one is the semantics. Without understanding the context of the data, there is no meaning to the remaining two on the top. If you're going and looking into a particular column, you want to understand is it a social security, is it a passport number, is it a driver's license? That context is very much important. So I just put that and as one of the categories, and the last one is the remediation in terms of cleansing, enriching, things like that. For each one of these categories, I started listing what problems can I solve using Gen AI. Because in order to use Gen AI, of course, we need to know, ask better questions. And so I kind of like listed the problem sets. The first one on observability. How many of you guys use any observability technologies today? That's one, two. That's way less than what I expected, but there we are using anomaly detection primarily to identify any trend deviation. Most of the platforms that today exist sends lots of alerts. Too many alerts that we cannot even comprehend. So there is an alert fatigue that sits in. That is a problem that we want to solve. On the data quality piece, for guys who raised that they're doing data quality, I don't know if you guys are doing automation or manual. Manual or a mix? Okay. So there, if you have written any SQL checks, you know how long it takes. Writing SQL is not, it's easy, but in order to constantly do it over a period of time, it takes a lot of discipline and also consistency. And then in terms of reporting, it's even a much more laborsome process. So that is the problem that we want to solve on that. And the third thing on the discovery is more like today in catalogs. Any of you guys use data catalogs? So in catalogs, it's very manual. The tagging of business context semantics is very tagging. You have to go one at a time and tag and etc. And that's a lot of painful time it takes, and then also the processes. Then if you have seen any tables, what you will see is a lot of times you have, for example, a customer information partially there in one CRM side, but on the SAP side or on the ERP side, you may have another part or a full record of sort. Systems which are siloed, transactional data operating, are designed to capture what is meaningful for their business process, but not in terms of a comprehensive angle. So this produces this problem of missing values all over the place, and that's a problem that we want to solve. And the last one on the remediation is, anytime we are cleaning, always we are looking for a golden record or a master record or some kind of reference data. And that's what we are talking here. There is always a need for something else to validate on before we can start some cleaning process. So I just kind of listed down all these problems here. And then I just kind of said, like, okay, how can I frame these problems into a little bit better questions here? So what observability metrics among the ones configured has high deviation? When I have thousands of alerts, I need to have a way to prioritize and then also use what that. So I'm using the percentage change, deviation as a metrics to solve that. And then here on the manual, how can I write more relevant SQL? Relevant is actually not appropriate SQL, it's more like context-driven SQL. So if I'm writing for a social security number, I want to check for length, formats, things like that. So including some other thing as part of the SQL is what that relevance is. On the manual tagging, really what we are trying to do is using data distribution as a way to identify similar columns which may mean similar meanings elsewhere in the data ecosystem. So assist in finding similar patterns to this pattern. And then the missing values is finding similar values, and then also on the reference data, what data could I use for cleansing and etc. Primarily trying to create some questions based on that. So I said, like, okay, let me go try. If I have a country and I want to replace it with a country code, let's see if ChatGPT can help it. So I kind of took that and put, like, what is a country for United Kingdom? So I'm from US, so my brain says UK, United Kingdom is UK. And so, like, I was thinking UK when I was writing this question, and the first question I asked is, what is the country code for United Kingdom? And it gave an answer of, it's +44. And once it came, then I like, like there is a phone number code. So I need to ask the question very specific. And then so I reworded it to what is the 3-letter code for United Kingdom. Still I'm kind of thinking UK, but I thought like U.K. or something like that. And so I put 3-letter code. And then it came with GBR. And then like, I never use GBR outside UK. Like, I always think United Kingdom is UK and not GBR. And then it just gave that, which makes sense. Then I said, like, okay, maybe it's a 2-letter code that I need to ask, and then I asked that, and it gives GB. Then finally, I got the right question. What is the abbreviated code for United Kingdom? Then it gave UK. So this process primarily tells me how important the prompts are from an LLM standpoint. So apart from your training data that you do, you also need to know what questions to ask to solve any problem, and that is the concept. We are going to take that and extract it into more of a bigger architecture here. So this reminds me of Socrates. I know you won't believe me, but the highest form of human excellence is to question oneself and other. And this is kind of almost like Socrates coming back in Gen AI world and saying, like, if you're going to be creating more of a Gen AI excellence, you need to know what to ask. And just for humor, do you guys think this is the Socrates picture, or? So actually, the picture I put is Plato, and that's kind of what I call as a hallucination. Most of the time, we think it is, but Socrates is on the other side, on the right side, thinking. But anyhow. So I just kind of took Socrates' philosophy and then changed it to this. In order to have the highest form of Gen AI excellence is to use effective prompt design. And then the author doesn't matter. So I kind of took all of these practices, what I found in a way, and created some kind of very short and sweet best practices. We know that LLM is at its infancy stage, which means that in order to get trust or in order to more automate at scale, you need these best practices together. So these are some 3 best practices I just kind of put together into it. The first one being prompt engineering. We saw like lots of different ways when you ask the wrong question, it go to a different model and gives you the wrong answers. So it's more effective and important to do the right prompt questions as part of this. The second one being here is the metadata piece. So when you're talking data quality and etc., everyone thinks that we have to go actually into the data and then try to find the problem. But then you get into all these issues of privacy, security, what if my data gets into the OpenGPT and all those steps. And so for me, like, there is a lot of information that is already abstracted in your metadata layer, and you can create more metadata to answer some of those questions. And in the demo, I will show some of those examples of sort. And even if you want to do more, you can use vector-based data. It could be like Chroma or any of those open source databases on top of your metadata repository, which could be embedded into that. So that embedding in metadata and the scope of what that data is very much important too. Third, I always believed in usability and user experience. So just throwing a chat interface and asking the users to go ask wild is a wild, wild west country. And I kind of feel more like it has to be more page context aware. So as the user is navigating into different tables, columns, and etc., that needs to be some kind of context, user-aware context that needs to be fed back into the architecture, which allows you to be more event-based action. So if I'm there in a particular table, I know what columns they are, what changes I can do, things like that also. So those are 3 of those things that I would like to combine as a best practice as part of my architecture. So as a result, what we ended up is creating a DQLabs AI Copilot. And the Copilot here, as you can see here, has can you guys see this clearly from the far end? Okay. So the first one is the metadata repository. So we connect to almost all the different data sources using connected types. But we take metadata information, what we need, and put it into a DQLabs metadata repository here. And we use that to train our models to make metadata aware. So the second thing is, I was kind of talking about this user context aware navigation here, which is this page aware mechanism. As user is navigating into a digital application or a portal, you want to be knowing what the user is where, and that page aware is another information that could be fed into the model to be even making it more reliable, more context driven, and not being very generalized. The third thing is the event aware. The event aware is more around, okay, if the answer is this, what actions can I take on? So that comes back to primarily using some of the APIs that we have to interact with the application or back to the source databases, and then creating that. So these three are the data that has been fed to create this foundational model. So now your data is not exposed. It's more the metadata that has been constrained. And then your page aware, event aware makes it more usable and user-friendly in terms of context. And then now you put an NLP interface on top of that, you have a chatbot that is available for use. So that's kind of what we have built as an architecture, and use some of the best practices, what we saw in the prompt engineering, in terms of embedding, in terms of building a vector database on top, and then also providing this contextualized chat interface. So this comes down to as we go into explore some of these use cases, my approach always has been is more the crawl, walk, run. With automation, as you scale, you also need to be directly proportional to trust. So you cannot just use 100% automation with no trust because it doesn't go anywhere. So these are some use cases we just kind of said like, okay, we'll take some of these use cases, something very low, lightweight, but in a way that we can demonstrate the architecture in a powerful way that it can be scaled, and then kind of further expand and as we build the trust, etc. So here you can see like there is so many different things that we can see: identify problems, recommend missing values, help in writing SQL checks, and then even in terms of compliance and sensitivity, which we kind of put as an anomaly, you can identify sensitive data using some of this data distribution and things like that. So before I go into the demo, I thought I would just give you briefly an idea about what DQLabs does, so you kind of get the idea and set the stage from a platform. So we are a unified platform, and which kind of combines different capabilities such as observability, semantic layering, data discovery, and then also business data quality using AAML, which is augmented data quality. We have it all in one platform, and the best way to visualize this triangle, think your organization hierarchy is this triangle, top to bottom. On top is your leaders, your data leaders who are making decisions, or your CEOs, CXOs who are using KPIs. While on the bottom is your data infrastructure, which is very foundational and critical for your success of any data-driven strategy, where the data engineers reside. So here at this bottom layer of production of data, we automatically use observability as a capability and identify any data reliability issues. Is the data there? Is the pipelines moving the data, bringing the data to the warehouse, or is there any pipelines broken? All of this is automatically observed. One step up, we have this semantic layering. Using this data distribution that we aggregate into the metadata repository, we automatically identify what is the business context for each of the column. So this could be as simple as like this is a city column, this is an email column, or it could be as more powerful for an organization, saying like this is a product name that means a lot more specific information within an organization context. But by understanding the semantic layer, we are able to standardize all these checks, empower everything without asking the users what checks are meaningful for this particular column or etc. That is an automated process that we do. And on the top, we have an ability to use lineage plus other metadata to link a KPI back all the way to downstream, and then also show that information of so. So with that, we'll just go to a quick demo. So this is the home screen. So we show all the information in a much more easier, friendly way. Hold on. Sorry about this. All right. Oh, God. Okay, so So here is the home page of this. And then if you see this, we provide multiple options to navigate through this. These are all the different tables in your ecosystem, which has everything marked as scorecards in terms of scores, in terms of alerts, in terms of issues. So I'm going to be using this ChatGPT interface here more to ask some questions and interact with the system. The usual way until now, what we have been doing is providing these portals, providing lots of dashboards as below to cover all this information of what you're looking as here. But I'm going to use this interface more and do some of these things that we are doing. The first thing is I want to ask, like, show the top. So now what it's primarily doing is it's primarily going back into the architecture what we talked and created a foundational model which is driven by metadata model, which is the metadata repository that we created, and is able to answer some of these questions. I want to know what is the most utilized asset out of the box, and I'm saying, like, show the top queried asset, and it just gives me immediately this. But it gets a little bit more fun. I can say, like, show me the most used asset with the lowest score. So what I'm typing here is, sorry for folks who cannot see, I'll read it. I'm kind of saying, like, show me the most used asset. I kind of like change the word in a different way and then ask which has the lowest score. So I'm kind of combining multiple different metadata attributes and then kind of asking to prioritize my decision of what I need to really look from a data quality standpoint in terms of my day-to-day action. This could be even furthermore. I can say, like, show the most used asset with issues. So maybe that table did not have any issues at all, but I want to find out something that has more issues, and now I find this customer AI table has 4 issues of that, which I want to do it. Now I can do even more, the opposite, show the least used asset with the So I'm asking, is there a table that has highest quality, but however I want to use it from a data literacy standpoint, which could be used for reporting and stuff like that. So it's kind of the inverse of what I was asking in the past. And then now it kind of gives you that information too. And this is kind of a little bit cool because I always have this, when people use trust, they are really meaning something very specific that is very specific to an organization. Now with the use of this architecture, you can even simply ask questions like, show me the most trusted asset. And it uses all this information in terms of issues, alerts this, and gives you that feedback right away. And this is fascinating for me because now we are able to quantify what trust really means, but also importantly, go from that to a particular action of sort. So I'm going to go a little bit into one more step and then pick this one particular table. I want to show a little bit about the page context. So now when I'm at a particular page like this, now I can simply come here and then create. Let me refresh this and then click. So now I can take that one more step and create a measure where account underscore balance is not null. And I'm at a specific table here, as you can see, customer table, which is sitting in Snowflake. And I'm just kind of writing the SQL, not even writing the SQL, I'm just telling, create a data quality check where account balance is not null. So this not only converted this statement into a SQL, it used some of this event aware and went back and created actually a data quality check for us. So if I go into this property now and then go further down, I have this quality that has been created. And if I go into this edit mode, you will see the query. And I can validate this query and get the records. And then also, like, it has already configured. And now I can run this query as I do it easily. So this is like combining this page aware event aware, and also this metadata aware to know like this particular column exists in this table and blended it as part of this NLP interaction. Now, if I want to go further more, I can say like even a little bit complex. I can say like get the top 5 cities with highest average credit limit, which is not null, and average rounded off to so I just kind of put something very complex SQL in a way that I'm asking like not only use the metadata but also use some of the data. So I'm saying like get the top 5 cities with the highest average credit limit. So it's going to go into a particular column. It knows what column it needs to look. I'm not telling what column here. And then furthermore, I'm also asking it to average on another column, which is a credit limit, and plus also do some calculations on top of that and give this decimal points. And so this is kind of an example of to show you that we are kind of in a more secure way bringing down the amount of data to process limited, but also more secure, but also more page aware and event aware, and bring that all in this information. I got the nod for the time, so I just want to give some time for you guys to ask some questions. So if you guys are more interested in, we have a demo. Any questions so far? Sure.
Hi. Thanks very much for the very insightful presentation so far. I've got a question. So we tried to kind of create a similar tool internally.
Hold on 1 second. I cannot hear you.
Oh, sorry. So yeah, I was saying we tried to create our own tool using GPT and querying some logs and some. And one of the issue we came across was related to the fact that those logs and the large data sets often require recursive queries, and which are very expensive with GPT because every single time you send a query, you get billed. So did you find a way of dealing with it? Or?
Yeah. It's interestingly, we talked about it a little bit before. Yes, like for example, if you're asking for a missing column value, you are kind of keeping on reiterating to 1 billion rows, and even if it's an exception data, it could be 500,000. Still, it's kind of a costly process. So on the remediation side, what we are doing is when we know, like for example, this two-letter abbreviation for United Kingdom, once we get one time, we store that history information to also power some of these workflows automatically instead of going back to ChatGPT. So use it wisely in a way that we do it once, and when you get the information and when it is a good information, when you get that feedback loop, then you also kind of use that same versus going back to the API calls. So that's kind of like a reusing and some of these concepts built as per the workflow. Any other questions?
Hi, Raj. Thanks a lot for the presentation. It's been super informative. And I see that how data quality could be quite impacted with generative AI. A couple of questions here. In the architecture diagram you presented, you had LLMs towards AWS, one towards Snowflake, one towards Databricks. Are those LLMs fine-tuned? Is my first question. The second question is, in terms of the metadata store you have, I believe that's one of the main sources of information for the model, the LLM model, to understand where to find the information. I'm just trying to understand how you're enriching the prompt with that data.
Repeat the first question. What type of LLM you use?
Not exactly the what type of LLM, but have you fine-tuned those LLMs for those sources?
Yeah, that's a very good question because in the presentation I didn't address about the feedback loop. One of the things what we are trying to do is thumbs up, thumbs down. So when we have provide that interaction back into that NLP-based UI, what we are going to put is also a feedback loop. If the answer is wrong or if it is not working, then we kind of take a thumbs down, thumbs up, and that kind of will act as kind of like a supervised learning model to infuse what went wrong and then try to see if there is any more additional metadata information that we need to append on furthermore. That's what we are planning to do that on that one. On the second one, what is the question? Oh, okay, maybe I can, they're saying like finish, but I can talk to you.
We can actually take it outside the conversation, that's fine. Thanks.
Thank you. Thanks, everyone. Thanks for your time.